times derivative of the top minus the top times the derivative of the bottom. So that gives me x plus 1 minus x plus 1 all over x plus 1 squared. Okay, so 2 over x plus 1 squared. Okay, what we do to find the critical numbers is we have the numerator equal to 0 and the denominator equal to 0. The numerator is going to give us all the places where the slope is 0, and the denominator is going to give us all the places where the slope does not exist. Okay? Would 2 ever be 0?
No.
No. So we're good there. Would the denominator ever be 0?
It could, yeah.
At negative 1. So I have a critical number, x equals negative 1. But is negative 1 on my interval? No. So do I have to use it?
No.
No. But what if it was on my interval?
How to use it?
Then I would have to check it. This time, it's not going to matter, right? What are the only 2 points we plug in? 0 and 3.
The numerator shows you what, and the bottom part shows you?
Numerator shows you where the slope is 0. Denominator shows you where the slope is undefined. Does that make sense? Okay, so I just need to plug in 0 and 3. If I plug 0, what do I get? Negative 1 over 1, so negative 1. And if I plug in 3, 2 over 4 is 1 half. So max. Where does it occur? At 3. Is my n? Negative 1, and where does it occur? At 0.
What were you saying about the sharp corners?
If you just sharp corner like value, remember there are places where derivatives exist, but they could be a number. Okay?
Usually those areas are like lower than a
Yeah. But they could be, yeah. It's usually a change. Okay. So how do we feel about absolute extrema?
That makes sense.
Does every continuous function have to have absolute extrema?
No.
But the absolute...
Yeah.
Yeah, remember that was the extreme value theorem. It says every continuous function has to have absolute extrema on an interval.
Even, okay, so, but horizontal lines, their absolute extrema is their minimum as well.
Yes.
Okay.
That's why we use the inequality with the equal on it.
Okay.
Okay. So, there was that fun theorem. Woohoo! Now we're ready for the most important theorem of this semester. Nope. The MVT. Mean Value Theorem. The MVT. AP loves to test the MVT. And the MVT is really, really super important. Okay? Here's what it says. If, make sure I get my terminology right, f of x is continuous on the closed interval a to b, and differentiable on the open interval a to b, then something has to be true. And I'll tell you what that is in just a second. Get everybody caught up. Drum roll. It's a theorem, so what am I going to do? Draw a picture. There's A, there's B. I'm going to draw a nice, pretty polynomial curve. F of A, F of B. So we're continuous on the closed interval, differentiable on the open interval. What does differentiable mean? You can take a derivative, so no sharp corners, no weird things going on, no vertical tangents. Nice, simple curve. Okay? Anyone know what mean means in math? Average. So this is all about average. Okay, it's about an average value. And what the theorem says is that if I take f of a minus f of b divided by a minus b, what is that, by the way? Slope of what?
1 point.
Tangent line.
Not the tangent line. Slope of the secant line is the average rate of change. Okay? So the slope of the secant line has to equal the slope of the tangent line at some point on the interval. At some c on the interval a to b. Notice it's the open interval, not the closed interval. You cannot use an endpoint for an answer to an MVT question. So, where on this curve is the slope the same? It's got to be parallel, right? So, I'm going to go to this bottom one first. How about right about there? Would that be parallel? Okay, so that I'm going to call C1. Is there anywhere else? Yep. Right up here. So the MVT guarantees that there's at least one, but there could be more than one, where the average slope is the same as the instantaneous slope. The example I like to use for this one that makes it all make sense to people is think about yourself driving on 121 and you're going through the toll booth. Okay? Speed limit is 70. Okay? Do they record when you go through one toll booth and when you go through the next toll booth? Yes? So they know the distance you've traveled and they know how long it took you to travel. So could they compute your average speed?
Yeah.
Yes. Okay? That is your average rate of change. If the speed limit is 70 and your average rate of change is 75, were you speeding somewhere between the toll booths?
Yeah.
Yes. Because somewhere on that interval, your speed had to be the same as the average. Does that make sense? Aren't you glad the North Texas Tollway Association, or whatever they are, administration, whatever they are, can't issue you a speeding ticket?
They can in Europe, though.
Yes, they can, because that's what they do. They record your time and your distance traveled, figure out your average speed, and if your average speed is higher than the speed limit, you're busted. Does that make sense? Everyone see how that works? Okay. Here we go. Let's do an actual calculus problem with the theorem. Okay. Find the C guaranteed by the MVT for f of x equals sine of x from 0 to pi. So find the C guaranteed by the MVT for f of x equals sine of x between 0 and pi. So what does MVT say we should do first? Slope. So I'm going to do f of 0 minus f of pi over 0 minus pi. Everyone agree? So that's going to be, what's the sign of 0?
Isn't it
What's the sign of pi?
1.
No. 0. Over negative pi. So what's my slope for sine between 0 and pi? 0. That makes perfect sense to me. Because what does sine look like between 0 and pi? Looks like that, right? What's its slope? 0. Okay, just kind of makes sense. What do I need to do with that number? Equal to the derivative. So f prime of x is going to equal cosine of x. I'm going to set that equal to whatever we got for the slope and solve. Where does cosine equal 0 between 0 and pi? Pi over 2. Okay, should we try it again? Just to be sure we got it? We're getting the process though? Okay. Do I need to leave it up there for a minute, or are you guys okay? We've only got 2 more examples, so we're actually getting close. Okay, here we go. Find the C. Guaranteed by the MVT for f of x equals 3x squared minus 5x plus 2 on the interval 0 to 3. Okay, what do we do first? Now, I have people every year that do f of 3 minus f of 0. Okay?
Yes, as long as you put 3 minus 0.
Yep, as long as you're consistent, doesn't matter. Okay, so I'm going to plug in a 0, and that's going to give me 2. Then I'm going to plug in a 3. That's going to be 27 minus 15, which is 12 plus 2, 14. All over negative 3 equals negative 16 thirds. Is everyone okay? Stop me if you're not. Because tomorrow they'll probably have the same questions and I won't be here to answer them.
Why is it plus 14 and minus 14?
Oh, it should be. See, you guys are so much smarter than I am. See, you were wondering. When you wonder, ask. That makes the problem nicer. Why does that make the problem nicer? Minus 14, we said, right? So minus 12. So that makes the slope a whole number. Yep, ready? Oh.